Let's now talk about bitwise operators in C++. There are mainly 6 bitwise operators in C++, and in this video we are going to talk about first 3 bitwise operators. Let's first define what is a bitwise operator. A bitwise operator is an operator that works on binary representation of our input numbers. So if you are given two integers as input to this operator, right, we have applied bitwise AND operator, the first operator, which is represented using this signal, this sign. So what happens is it considers binary representation of both the input numbers, both the operands of the operator, right? Binary representation of 3 is going to be some leading zeros and 1 1 at the end. Then binary representation of 6 is going to be some leading zeros and then 1 1 0 at the end. If you consider 32-bit representation, then there are going to be 29 zeros and then 1 1 0. So what this operator does, it goes bit by bit and does this. For 2 bits, the output is going to be 1 only when both the bits are 1. If you see all possible 4 cases, right, the output is 1 only when both the bits are 1. And that's what happens here. So 1 and 0, one of them is 0, output is going to be 0. 1, 1, the output is going to be 1. 0, 1, output is going to be 0. And before these 3 bits, every bit is 0. So in case of 0, 0, we are anyways going to get 0. Right? If you have studied digital electronics, you must have studied AND gate, right? And that's how AND gates work. And that's what we are doing here. That's why this operator is called bitwise AND operator, right? It considers binary representation of the numbers, goes through bits one by one, and applies logical AND gate, right? And whatever you get after applying the logical AND gate on individual bits, you consider decimal representation of this number, and that's what is going to be your output. So what is the decimal representation of this number? See, all these are 0, right? 30 bits are 0. The last 2 bits are 1, 0. And this is binary representation of 2. That's why we get the output as 2. Let's now talk about our next bitwise operator, which is bitwise OR. In case of bitwise AND, output was 1 only when 2 bits were 1. In all 3 cases, we had output as 0. Here we have output as 1 in 3 cases and we have output as 0 only when both the bits are 0. So OR operator says that either first or the second bit, if any of them is 1, then the output is going to be 1. That's why it's called OR operator, right? So 0 1 1, 1 0 1, 1 1 1. So if you see this example code, bitwise OR operator is represented by this. This typically is there with shift backslash, right? In your keyboard, if you type that, you will get this operator typed. Now, if you look at the binary representation of these numbers, 3 and 6, this is binary representation, and if you do bitwise OR one by one, like if you've studied digital electronics, OR is also a gate, right, in digital electronics. So 1 0 1, 1 1 1, 0 1 1, and rest 29 bits are going to be 0. If we consider 32-bit representation, right? Please remember, in C and C++, standard does not say anything how many bits are to be used for binary representation, right? Different implementations may have different representations, different number of bits. So here I'm assuming 32. So what happens when you do this? You get this binary representation, and this is having 29 zeros and 3 ones. And what is the decimal value of 3 ones? It's 7, right? So output is 7 for this. Let's now talk about our third bitwise operator, which is bitwise XOR operator. This is the sign for bitwise XOR operator. You can typically get it with shift and 6, right? In your keyboard, there are numbers 1, 2, 3, 4, 5, 6. And if you press 6 with shift operator, you will get this operator type. Now, this is again like logical or digital gates. There is an XOR gate. And how does this gate work? If you have both the inputs bits are different, then output is 1. If otherwise, it's 0, right? In this case, if you see all these 4 cases, right, out of these 4 cases, in 2 cases we have different bits, so we have 2 times output 1 and 2 times output 0. It's different from bitwise OR only in this case. In this case, bitwise OR was giving us 1 and it's giving us 0 because both bits are same here. Now let's see the output of this program. We write the binary representation of 3 and 6. That's how all the bitwise operators work. They consider the binary representation, they traverse all the bits one by one, and then they produce output. So 0 1, their difference output is 1. 1 1, same output is 0. 0 1, different output is 1. And remaining 29 bits, all 0, right? So output is going to be 0 for all 29 bits. So we are going to have this output 1 0 1 and its binary representation of 5. That's why we get the output as 5. So these are first 3 bitwise operators. In the next video, we are going to talk about next 3 bitwise operators in C++.